Good day and welcome to Class Time, your daily classroom for CSEC students. Watch this lesson in real time on Television Jamaica's YouTube channel or One Spot Media. Also a repeat later on JNN at 5 p.m.
In today's lesson, we will be looking at problem solving in measurement and statistics.
I'm Denise Bailey.
And I'm Shadeen Cassie.
So today we're looking, as we said, at measurement and statistic, problem solving, featuring the measurement and statistic.
Right. So looking at problem solving, we're going to start out with this quote to say that it is better to solve one problem 5 different ways than to solve 5 problems one way.
Yes.
Denise, what's your opinion on this statement?
I am in agreement with this gentleman, Mr. Pollia, George Pollia, who is saying to us that if we can build up our repertoire or skill sets, then we'll be better able to solve multiple problems outside of whenever we work at solving problems many different ways. We always have a choice.
Right.
So that is one of the things that we want to look at today.
So it gives us options.
Options. Right. So when problems come,
different problems come, we can find a different,
always pull. Yes.
A different strategy, right?
That is correct.
Yes.
That is correct.
Let's move on.
So
our colleagues before would have been looking at a series of problem solving lessons. So let's just recap what the problem solving sequence includes.
Yes.
Go ahead, Denise.
Okay. So the same George Pollia, he came up with this strategy sequence. We have to understand the problem, see what the problem is talking about. We have to devise a plan, know what to do to solve the problem.
Right.
We have to action that plan.
Yes.
And then look back to see if the problem that we set out to solve in the first place was actually solved.
So you don't just get a problem and then you start solving.
That
right?
is it.
We try to follow the sequence. So make sure to understand,
yes,
have a plan,
yes,
do the plan or carry out the
yes,
action, and then we can go back and double check to see that the plan worked.
Yes.
Okay.
Yes. So that is what we'll be using today. So just to recap, when we say in the problem solving sequence, understand the problem to see, we're basically asking some questions. What am I trying to find? And in that, we tell what the question is asking. What do I know? Because you have to understand to be
so
able
by
to
reading
solve.
and interpreting the question based on what you would have read, what do I know? Identify key facts and details.
Yes, yes. In the sequence, we have devised a plan.
And in devising a plan, we need some strategies, right?
Yes.
What strategy or strategies should I try? And here are some suggestions.
Because there are multiple ways to solve problems. But as was said before, if we become astute in using any one of these, then we're able to apply it to multiple situations.
Yes. Unrelated situations.
Unrelated situations.
We could just merge some of these techniques.
Which is true.
Strategies to come up with a solution or with a plan.
That is right.
So some of these are act out, make a drawing or a diagram, look for a pattern, construct a table, guess and check,
work backwards, solve a simpler or similar problem, use reasoning, and write an equation.
Good.
And there are others, but we'll just
stick to these for now.
Yes. Mind you, we'll not use all of them, but they are options. It's good to have options.
So in carrying out the plan, what does this mean?
You do it.
You do it,
yes,
right? What can I show? What can I show the problem? Try drawing a picture. Yeah. You could do that depending on what the situation requires. Making a table or a graph, or act it out. Do some form of modeling. And what does acting it out means for you? I'm doing a math problem. How do I act it out?
Bringing it into the real life space. If I'm in an area where I have manipulatives, let us say, for example, or anything within the real context, I can take up my unit cubes Perhaps, or I can use my duster or my eraser as a props to help me to better clarify and understand the problem.
Right, and there
Math.
might be other things in the environment that you can pull from, your strings, your rulers, whatever you could
Your
find.
clock, your shoes,
clock, yes.
anything.
And
Yes.
in doing this, we are making a model.
Yes,
Right.
that is it. That is it.
Now, how will I solve the problem? What is the answer? Can I tell the answer in a complete sentence? Is it a one-word answer? Is it a whole paragraph? Or is the answer just numbers? All right.
Okay, all things for us to consider, right? Good. And afterwards, we have to
Look back. Make sure that our answer is reasonable.
Yes.
It fits the situation.
Yes.
All right.
Dare I say, it answers the questions that we were asked originally.
From the interpretation.
Very good, very good.
So, did check my work. So, did you check your work? When I check my work, I can compare my work to the information in the problem. Did I answer the question correctly? Be sure all calculations are correct. So you're not multiplying and then adding instead of you were to carry out a multiplication problem, right? Because sometimes these things do happen when you're actually trying to concentrate.
Yes.
So
yes,
it's
that is
human
true.
error.
Yes.
Yeah.
Focus.
Is my answer reasonable? Estimate to see if my answer makes sense. Make sure the question was answered.
Yes.
So in order to look back or to check, you have to go back to the original question.
Yes.
All right.
Yes. And I suggest that we do this consistently outside of exam situations, outside of the classroom setting, inside the classroom setting, so that it becomes a part of our problem solving technique and skill.
So in other words, what you're trying to tell us is that make the problem solving sequence a part of our everyday activities.
I would strongly agree that. And once we do that, we build up a skill set that can be used across the board.
Right. It's a lifetime skill.
Can I tell you, math is in everything that we do.
Yes.
Good. So let us apply this sequence that we just spoke about. And of course, we spoke about you would have done it in other strands before. Our focus for today would be in measurement and statistic. So our first task, you can see that we have the sequence here for you, just to help you to recap and to remember. So this is what we have. Task 1.
The bus schedule shows that buses leave from the transportation center in Kingston to Morant Bay every 45 minutes, beginning at 1:25 p.m. The last bus departs at 8:10 p.m. Buses departing before 3 p.m. have a travel time of 1 hour 20 minutes.
Okay.
Buses departing after 3 p.m. have a travel time of 1 hour 25 minutes. Which bus would arrive in Morant Bay closest to 6 p.m.?
That's a mouthful.
Right.
We have to ensure now that we actually understand what the problem is asking.
Yes.
Because this is much.
This is much.
Okay.
So in other words, in understanding the problem, we're trying to make sure that we break down this question, make it into smaller facts, bullet points that will be better able to see what the question is asking.
Can I say that the bullet points are manageable?
They are manageable,
Okay.
yes. Now, step 1, read and understand. What do I know? First, the bus leaves at
1:25 from the transportation center.
in Kingston.
The first bus leaves at 1:25 p.m.
Yes.
Good. I also know that every 45 minutes a bus leaves the center. Based on the scenario, we know that buses that depart before 3 p.m. have one set travel time, which is 1 hour 20 minutes. And buses that depart after 3 p.m., they have a set travel time of 1 hour 25 minutes.
Denise, can I point out too that in problem solving, your interpretation doesn't necessarily have to be the way that I'm going to interpret it.
That is
so
true.
I could be interpreting it a step at a time, while you'll be able to do a larger
Chunk.
portion, yes, to go a bit faster.
Yes.
So while speed is important, that is not the main point in problem solving. Right.
Thanks for that. I appreciate that. Yes.
What am I asked to find?
Well, which bus arrives in Morant Bay closest to 6 p.m.?
So of all the buses that are leaving Kingston after 1:25 p.m., based on the information that the question would have given, which of the buses will reach Morant Bay closest to... Right, so it could be 6 p.m., it could be 5:30, whichever way is closest.
It didn't say exactly at
No.
6. Okay, so we have to take that into consideration too.
Right.
All right, good. Now we have to plan and solve. Now, what strategy could we use? The strategy that we're suggesting, and you have said before, the strategy that I may select may not be the strategy that you at home would select.
So
but the
there's
strategy that we share,
We are sharing no.
Yes, maybe different from yours. So
Yes.
there is no
One way to solving a problem.
Awesome.
All
We
right.
have to remember that. So our choice, we're sharing with you, is to construct a table. And here we have the table. The table has the times of departure, the length of the journey, and the times of arrival. In the departure time, we know that each bus leaves at 1:25
The
p.m.
first bus
The first,
leaves
thank
at
you.
1:25 p.m.
Yes.
But a bus will leave every
45
45 minutes. So from 1:25, 45 minutes will take us to 2:10 p.m. and 45 minutes, and we keep going
2:55
until we
p.m.
find a bus closest to the 6 that will be leaving at
Yes,
5:10. But we are not sure if this bus will reach before 6
or after or
Right.
close, which would be close.
Right.
Okay,
so we
good.
cannot just look at what we
No,
have here
no.
to decide that, hey, the last bus will give us the answer that we require.
Can I say that there are times we in haste, we construct the table and we make an assumption. We jump into the assumption and say, yes, that is the answer. But we need to take the time. The process is important in problem solving. Today, we're building that process with you. So, buses that leave before 3 o'clock, there's something special about them.
They require 1 hour and 20 minutes to travel.
Okay, good. And the buses that leave after 3 and after?
Yes, bearing in mind that the traffic peak hour and all those stuff,
And the
it
roads.
might take 1 hour and 25 minutes.
Maybe longer. But for this situation,
Yes.
it's an hour 25 minutes.
Okay.
Fair. Now, we have this awesome task of now seeing at what times would the bus that leaves at 1:25 would arrive in Morant Bay.
Yes.
At what time the bus at 2:10 p.m. would arrive in Morant Bay. And we do that until we see which is closer
Closest.
to 6 p.m.
Yeah.
Okay.
Now, this would be basic calculation
Yes.
based on where we're at now.
Yes,
So
yes.
in order to find out the length, the time that it will arrive, we just go ahead and do our addition.
Yes.
To find out that
Yes.
the first bus, the bus that leaves at 1:25 will arrive at 2:45 p.m. The bus that leaves at 2:10 will arrive at 3:30 p.m. The bus that leaves at 2:55 p.m. will arrive at 4:45 p.m.
Okay.
The bus that leaves at 3:40 p.m. will arrive at 5:05 p.m.
Okay.
The bus that leaves at 4:25 p.m. will arrive at 5:50 p.m.
Yes.
And the bus that leaves at 5:10, which is pretty close to 6 now, will arrive at 6:35 p.m.
Question. Am I finished?
you have not answered the question.
Oh, so now I have to check. Even though I've had my strategy, I've actioned the plan, now I have to make sure that I'm answering the question that I'm asked.
Yes.
Okay.
So you need to answer the question, right? So what you would have done now is just to put your information together using a table or by constructing a table. Now you need to use this table in order to come up with a solution.
Yes.
So
Which time is closer to? The times that I see 5:50 p.m. and 6:35 p.m.
right. And the question wants us to find the
Which
bus that
is
arrives closest
closer
to 6
Okay.
p.m.
6 p.m. 5:55. How far is 5:55 from 5:50? Sorry, p.m. from 6.
That's 10 minutes away from
10
6.
minutes. Okay, and 6:35 p.m. How far is
We
that
are
away?
after 6 now, so that bus would not be the one. If someone was waiting for you in Morant Bay at 6 p.m., that person would have left 35 minutes ago.
Okay, so but I want to bring this to you. It says closer. I can be after 6, and I'm 3 minutes still closer than the 10.
And
so
it goes back to interpretation.
that is it.
Yes.
So this bus is 35 minutes away from 6. The bus that leaves at 5:10 p.m. is 35 minutes away from 6. The bus that leaves at 4:25 p.m. is 10 minutes away from 6.
And there is another bus too that is 55 minutes away from 6.
Yes, which is closer to the 6. The one that's
10 minutes, away from
35
6.
minutes, or the 55 minutes.
So it would be the one that is 10 minutes away
10
from
minutes away from 6.
6.
So we check our answer. In the time the bus departing at 4:45 p.m. arrives the closest to 6 p.m. and that would be our answer. Yes?
Yes.
Yes. So in problem solving, we have to be able to spend the time to understand the problem, spend the time to devise a plan to see which plan works best depending on the situation. Then we go ahead, we solve, but we have to check and ensure that the problem is
answered.
Yes.
You would have satisfied the requirements of what the question needed.
Yes.
Right, and that is important too. And our units, whether you want to give that in a sentence, whether you want to just give just a number, depending on what is required.
Depends on what is required.
Problem.
Awesome. Now here we have another. We'll just look at the task and you'll get some time to think about it. The task says, shown at the right are 27 cubes glued together to form a larger cube. They were painted yellow. How many of the 27 cubes have face painted, one face painted on, and how many have two faces painted on?
So, sometimes we might be required to read the question twice.
Can I tell
you?
To
make sure that you fully understand what the question is asking.
Yes, that's true, that's
right?
true.
You can also try pulling it apart because we're trying to interpret in the information. Remember to make note of your bullet points, and then you can use some time to try and act it out. See where this take you. You can go ahead now and select a strategy.
Okay. And that is what is required. That's what is required of us. As we go through, we can read, we would have read and understood. We know that there are 27 cubes that were glued together to make a larger cube. And we know that of the 27 cubes, that's what we need to find. How many have one face painted on and how many have two faces painted on. That is what is required. Think about it. As we go to take our break, and we'll be back with more problem solving.
Welcome back to Class Time, where problem solving in measurement and statistics. So we were at the point, what do we know from the question? And we are given 27 cubes that we are going to be gluing together. And of the 27 cubes, how many have one face painted or two faces painted? So it would be 27 cubes that we're actually gluing together in order to make a bigger cube.
So the strategy they are using there is you're actually acting it out.
Yes.
You're acting out the strategy.
Right. I'm acting it out. So I would have had my cubes and I'm going to be gluing 27 of these small cubes together in order to make a big cube.
Yes.
Now, the question asks us to find out, after gluing these cubes together, how many of these cubes would have one face painted, or how many would have two faces painted? Now, let's examine our cube that we would have connected, right? Looking at it, we can see that here would just have one face painted, right? And if we examine another bigger face, we'll see the one in the middle again with one face painted. So if we should examine the entire thing, we will find out that there are 6 faces
that were painted, on. Okay. 6 faces that were painted on.
Right.
Awesome. Now, we could act it out, actually put the cubes together to get the larger cube. And as you would have seen on screen as well, we could have a picture, make a drawing, and do the shading. So the other question that we're being asked is to find out how many have 2 faces painted on. And I would have gone ahead and done the gluing together of the cubes for you. So when we have the gluing together of the cubes, let us see. 2 faces highlighted by the yellow. 1, 2. 1 for this face that is out. 1, 2. For this face here, look at it. 1, 2. 1, 1, 2. 2 faces painted. 1, 2. So here we have in all 1, 2, 3, 4 faces painted with 4 cubes with 2 faces painted. Yes, and we would have done that for 1 face on the large cube. Now if we should turn the cube again, we would go through the process again to identify the number of cubes. Incidentally, when you look at this cube, the ones with the smaller cubes with 2 faces painted are shown to us in yellow. So again, we have 1 with 2 faces, 2 with 2 faces, look at it. 3 with 2 faces, look at it. And 4 with, and you could go through acting it out. Now for you older students, you would say, but I can just make a drawing or I can just use my reasoning. That is a plan that you can use. However, there will be times when one of the best options for you is to act it out. Use smaller problems to help you to better understand how to actually act it out, so that when larger problems come, more difficult problems I should say, come, you are able to use the strategy comfortably. And that is what we want to do or share with you today. So when we would have counted all the yellow cubes, because the yellow cubes here show 2 faces painted, we would see that we have 12.
A total of 12.
A total of 12 cubes that with 2 faces painted out of the 27 cubes. You don't believe me? Try it at home. So here we have,
look at another problem.
Task 3. Good.
Yes, and we're going to keep reminding you so that the problem solving sequence becomes a part of your daily activity.
That's right.
Understand the problem,
Yes.
devise a plan,
Yes.
carry out the plan, look back. Task 3. Owen needs to read 2 books from a list of 6 books.
Yes.
How many different combination of books are possible?
That is what we need to find out.
That is what we need to find
Okay.
out. No. So in understanding, what information, what do I know? Read 2 books from a list of 6 books.
That's right.
No. Did it give us the names of the books?
No, we don't
that
need to know the name of the
information.
book.
What am I asked to find? The number of possible combination of books from 6 books, but it's not just any amount of combination. It's really 2
A combination
of
with
2 books.
Okay, okay.
Yes.
So now we have to go plan and solve. What strategy could we use?
We could use our reasoning.
Yes, we could.
And remember, we are suggesting that there are different strategies too. We could have used another solution. We could have used a drawing, a diagram. We could have made a model, right? So it's up to you. But for this case, we are going to be using reasoning.
Okay. We are going to take a short break. More when we come back.
Welcome back. We are problem solving in measurement and statistics. Now let's look back at the question that we breaked with. So we have 6 books and we need to make combinations of 2 books. So we need to find out how many combinations
we can actually get.
Okay.
So we read and understood the problem and we know what we're asked to find, the possible
Yes.
combinations. The strategy that we have is use reasoning.
Yes,
and
we
as
are
we
going to
said,
be using
yes,
reasoning.
But you did say before the break that we could have used
a drawing or we could have
Yes.
modeled the situation, act it out, right?
That's right.
Go ahead.
So here we have the books. We are using the letters A to F to describe the book. So we're doing book A, book B, through to book F.
Yes.
Now, what are the combinations?
So I could match a book A with B.
So we could match a book A with B. Okay.
Or A with C.
Okay.
Or A with D.
Okay.
A with E. Or A with F.
Good.
We could also redo this by selecting book B, but this time we're going to be selecting book B with book C.
Why?
We would have selected A with B, and if we turn it, do the reverse, it would be the same 2 books.
Okay,
Right, so we don't
okay.
need to go back to A and B.
Good, because
Right.
that is already an existing combination.
Yes.
Good, good,
So we
good.
don't need to repeat. So it's book B with book C, book B with D, B with E, B with F. And we could just repeat this to find out the combinations.
Yes.
Now, after listing these combinations, how are we going to find out the number of combination with 2 books?
Well, we look at it as counting.
Count it.
Okay.
We just count up the number and see that there
Yes.
are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
It should be
15.
15. Oh, because we didn't have a combination with E, F.
And F.
Okay.
Okay.
But you know what is important for me here, Shadeen? The thing is, persons at home are saying, but hello, I could have done it another way. Good for you. Remember, you want at least 5 many ways to solve the one problem. We are just offering you one possible.
Right. But what they could do is to use a different strategy and see if you will get the same result.
That is right. Prove. So I do, you do,
That's
we compare.
one way of looking back using a
Yes,
different strategy.
That is true.
Yes.
Yes. So, of course, we said that there are 15 possible pairs of combinations from the 6 books. Good. We're getting into it now. No. Persons also would say that, look here, you're doing problem solving, but I'm going to be doing CSEC, and I'm doing problem solving with CSEC and all these things, and I don't see any CSEC questions. Well, here we go.
Yes, just looking at it, I'm seeing a quadratic.
Oh, my word.
I'm seeing P all over, and I know that this has to do with algebra.
That's right.
So we must be into CSEC now.
Okay, it's algebra. Let us see.
All right.
So a farmer wishes to enclose a rectangular plot with a wire fence. The width of the plot is 3 meters, less than its length, P. So the width is 3 meters less than its length, P.
And Denise, if you notice, you repeated it.
Yes.
It means that reading it again will help you to understand or interpret the question.
Now, given that the area enclosed by the fence is 378 square meters, show that, and we come to the quadratic now, P squared subtracting 3P subtracting 378 is equal to 0.
So that's what we need to show.
That's what we need to prove. We're going to show that this is so.
Step 1.
Step 1. We read and understand. What did we understand?
I know that the width of the plot is 3 meters less than its length, and the length is P.
Awesome.
The area enclosed by the fence is 378 square meters.
Good.
What am I asked to find? I am to show that, I'm to prove that P square is equal to 3P P squared subtract
Subtract
3P subtract 378 is equal to 0.
Mercy, let us see if we can prove it now. So how are we going to solve this one? What's my plan of action?
So we did not take all the information from the question.
Okay.
It gave us that we are looking at a rectangular plot.
Thank you. So, because that is important in order to go solve now.
Right. Now, what does a rectangle look like?
I know.
Right. So that's information, and we are pulling from what we already know and putting it here to help to solve this problem.
Okay. The strategy or strategies we use, we can make a drawing.
Yes.
And write an equation.
Good.
The drawing, what would the drawing look like?
So it did tell us that we're working with a rectangle.
That's true.
It did tell us that the area is 378 square meters.
Yes.
Right? And we know what area is.
Yes.
Enclosed in the figure. It also gave us a length as well as a width.
Okay.
So the length in this case is P. The width is
P subtracting 3.
Now, how do I get P squared, subtract 3P, subtract 378 to be equal to 0?
From all of this?
From all of that.
But I am going to use an equation because I may not be able to answer that just yet. But I know
what an equation is, and you know how to find
the area of a rectangle.
Good.
So I'm going to write an equation, and I start off the area of the rectangle is equal to its length multiplied by its width. Now we have the information from the drawing, so we are now taking the information from the drawing, placing it into the equation, and this is what we get. Good.
So you would have used the drawing to summarize the question that you were given.
True.
Yes.
Make it visible for me.
So all the information that you need in order to create this equation is embedded in the drawing. Okay. So the area of the rectangle is 378 square meters, and we know that to find area, we use the formula or the equation length multiplied by the width.
Which is shown here.
It's shown right there.
Yes, but I still don't see how we're going to... Let us show me. Since it says show me.
All right. So, in summarizing all of this, we will see that 378 is actually equal to P into, and I say into because the width would be in brackets.
Oh, so this is what this... Okay.
Right. So into will show that it is enclosed in brackets. So it's the length P into or multiplied by the width, which is P subtract 3.
You know, I sing a little. I think I sing it, you know.
Right.
Let us look.
So we are going to be applying the distributive law.
I get it.
And you would have been exposed to the distributive law, grades 9, 10, all the way up, right? So you're ready for CSEC. So P multiplied by P, and that is added to P multiplied by negative 3.
Are you seeing the answer? Oh, wow. Okay, so I am seeing 378 is equal to P squared minus 3P, or 3 squared subtracting 3P.
And we're going to pull again from the laws of indices.
Okay.
What is our product when we multiply a number by itself?
When we multiply a number,
right, or we are multiplying an index number with the same base, right? So the index is not really identified, but we know that it's 1.
Yes.
So we can go ahead and...
Which is how we get the P squared here. Yes.
So P multiplied by P raised to the first power multiplied by P raised to the first power will give us P squared.
Yes, but they know that, you know, because they do the...
They know that. So we are just putting it into this situation.
Good. Just in case. Okay. So how am I to get it from here to here?
So we are to equate this to 0.
Okay, how may I equate it to 0, miss?
All right, so we need to ensure that in balancing our equation, 0 is left on one side.
One of the sides.
Yes, and in order to leave 0, it's easier for us to just transpose and remove the transpose 378 than to be transposing
Going all of
the
P squared, subtracting 3P.
So when we subtract 378 from both sides,
yes,
then 0 will be left.
Oh, but see, here it is.
Yes,
here
right
it
there.
is.
So
Here
we
it
would
is.
have answered the question.
Yes, we would have answered the question. So we would have shown. But what I want us to appreciate here is that we made a drawing. From the drawing, we pulled all the information. We summarized our information. From that, we used our
Previous
equation.
knowledge.
Exactly. Previous knowledge, which tells us which of the equations we are to use. Pull the information from the drawing, plug it into the equation, and then we went ahead as per usual.
Yes.
Okay. So it works even for CSEC.
It works for CSEC.
Okay. So let us go. Ooh, please go back one for me. So this is another. The mean of 4 numbers is 71.5. If 3 of the numbers are 58, 76, and 88, what is the value of the 4th number? Okay. Understand. So we read and understand. Read and understand. What do I know?
What information were you given? What do I know? I know that the mean of 4 numbers is 71.5. I also know that I'm given 3 of the
those
4
4.
numbers, yes, and the numbers that I'm given are 58, 76, and 88. What am I asked to find? I am asked to find the value of the 4th number.
Okay. I can work with that.
Hold on. I also know what the mean is.
Yes.
I know what yes.
So the mean would be the end product now.
Right.
Okay. So that gives me an idea for the problem solving
Right.
strategy, because now I'm starting.
Okay.
with
What do I do to find the mean?
Exactly.
Right.
Exactly.
So I'm thinking about it.
Okay.
Now, what strategy or strategies should I try?
Could. Because remember, there are more than one strategy.
And your
that could be
interpretation
applied.
is different from my interpretation.
Yes.
All
and
right.
my problem solving skills and competencies may be different from yours. I may be able to solve many problems, and so I quickly can pull from the multiples that I have, while somebody else would just have been practicing 2, and so they are forced to work within the confines of the 2.
Yes.
We don't want that, don't
All
it?
right. So for this case, you will be using
Working backwards. So from working backwards, as you highlighted before, I know what my end result is. The mean, which is 71.5.
Right.
The mean is 71.5. Now I'm going back. How do I find the mean again?
What did you do to come up with
That
the 71.5?
is it. The sum of 4 numbers. 4 numbers divided by 4. That's how we found the mean to be 71.5.
Yes.
Going back, to get the sum of the 4 numbers, we would have had to do what? To get the sum of the 4 numbers, we would, well, I'm going to multiply the mean by the
71.5, because that's
the 4 numbers by the mean.
So if you look at the step before, it's the sum of 4 numbers divided by 4. So what did I divide by 4? What is the sum?
Exactly.
To get the sum, then what I'm going to do is to multiply.
Do the reverse.
Do the reverse.
Okay, good.
71.5 by 4.
So when I do that, that's simple computation. It's 286.
Right.
But I'm not.
You were not asked to find the sum.
No,
you were
but that is the total for the 4 numbers.
Right.
But I only got 3.
No, you added 4 numbers to get 286, and you only have 3 of the numbers.
We get that, man.
All right, go ahead.
Yes. So what I'm looking at is that I have my 286. I know that I had to have added 88, 58, and 76. Added to another number, which,
and in this case, you're using n to represent that
number. The one that I don't know.
Right.
So we okay with this?
Yes,
now?
we are okay.
We are okay with this.
So the 4th number would be 64.
So what you're saying is we would add 64, 76, 58, and 88 to get a so I'm checking now, to get a total of 286. To find the mean of these four numbers, I would divide by the 4 in order to get 71.5. So the value of the fourth number is actually 64.
64.
Awesome. Yes, working backwards fun.
Yes.
Okay.
Now we have a sixth task. Mr. Brown has a field in the shape of a sector of a circle with center O and diameter 25 meters.
Okay.
Angle POZ is 90 degrees.
Okay.
Calculate the area and the perimeter of the field. In this case, you are to use pi to be 22 divided by 7.
Okay.
And are you seeing any form of CSEC coming out
Yes,
here?
and this is a CSEC question. This is a CSEC question.
Yes.
We would have read and understood, and when we read and understood, we know that the field is in the shape of a sector. We know that the center is O. It has a diameter of 25 meters, and there's an angle that is formed to get the sector POZ that is 90 degrees. Good? I'm missing anything?
You're not missing anything, but we could, while thinking about it, do some further breakdown to say that if I have the diameter, then I would automatically find the radius.
Because the sector, if it's a 90 degree sector.
And there is a sector, then it's 2 radii and an arc that I'm thinking about.
That is right. That is right. And what am I to find?
You are to find the area and the perimeter of the field.
Okay.
Now, if I would have thought about all this information, I know what a sector looked like. What strategy am I going to be using?
You see, because I know what a sector could look like, the strategy that I'm using is I'm going to draw a diagram, make the diagram, and I'm going to write an equation.
Okay.
And make the diagram to make the information clearer for me.
So you're summarizing the question.
Thank you. Thank you.
All right.
Thank you. So,
It's okay.
It's okay. So we would have had the diagram. I'm not sure what happened, but we would have had the diagram
Probably
where to find
at the end of this.
the perimeter of the sector, as you would have said, would be radius added to the length of the arc. Now we know what the radius could be, right?
Yes, because we were told that the diameter is 25 meters, and we know that 2 radii makes 1 diameter. If we divide the diameter by 2, then we can find a radius to be 12.5 meters.
Okay. And of course, we would have known how to find the length of the arc. So we would have written our equation. We would have plugged the information into the equation. And of course, here we would have had we use the information pi is equal to 22 divided by 7, and we know that the radius is 12.5.
Yes.
And of course, it would be for us basic computation, and we would have got our perimeter of the sector, which is?
No, we would have found the length of the arc to be 19.64 meters.
So what else would I need?
Find the perimeter, I'm just going to be adding the distance around. So the distance around this sector would be radius, arc,
length
right? Length of the arc.
We
so it would be 19.64 added to 12.5
added to. Okay.
To get a final perimeter of 44.64 meters.
Awesome. So we are okay. Here is the diagram, which is the sector, the field. Thank you. Good. So we use the equation. We wrote the equation. Now again, we're using the diagram to assist us. This time we're finding the area of the sector.
Right, so we know that the area is the enclosed space within the sector itself.
Yes.
Right, so this is given by a formula for finding. We can use the equation, and that is angle divided by 360 multiplied by pi radius squared.
Yes.
The rest is history.
The rest is just plugging in the information
and doing the calculations.
Yes, and of course, at home you would have been able to do this. Yes, and
before you go though,
yes,
persons might ask, why am I seeing 25 divided by 2? And we need to highlight that we are not using the diameter in the formula.
Yes.
We want to find the radius.
And the diameter is 25. So the relationship between the diameter and the radius would take us
require
here.
that we divide by 2.
Okay. This is. And so, problem solving or task. 60 students took an algebra test which comprised 15 multiple choice questions. The number of correct answers that each student obtained is recorded on a table or on the table. From the table, we are to determine the number of students who have exactly 13 correct answers, the modal number of correct answers, and the median number of correct answers. Now,
what do we have?
Yes.
What do I know? 60 students took an algebra test.
Yes.
So the sample space is 60.
Good.
There were 15 multiple choice questions. Information was recorded on a table. What am I asked to find? The number of students who had exactly 13 correct answers, the modal number of correct answers, the median number of correct answers.
Strategy.
I'm using reasoning.
Yes.
You can use whatever. If you want to model
yes.
or act it out, you could go ahead.
Yes, you could go ahead. But I want to just plug here quickly to say that the strategy you choose is heavily dependent on the situation you have. The strategy you choose is heavily dependent on the situation you have. In this case, we have a table that is illustrated here. So we have the table with our information. We're going to use the table to now reason. Right?
To see.
Good.
Right.
Yes. So there we have number of correct answers, 8, and the number of students, which is 6. Number of correct answers, 9. The number of students would be 14, and we can go along to 15 number of correct answers, and we have 10 students who got 15 correct. Now, what are we asked to find?
We are asked to find how many students had exactly 8 correct answers.
13.
13 correct answers. Sorry. We need to reason this table out. And in reasoning the table, what does 8 correct answers with 6 students mean to us? If we were to put this in raw data, I'm acting out the situation. What does 8 means? It would be 8 students. 6 students with 8 marks.
Yes.
Right.
Yes.
So I will have a list of 8.
Yes.
Just 6 8.
Raw data. 8.
Yes.
8. 6.
So what they want to find is how many students had exactly 13 correct answers. So I could find that on a table and see that it's
there
11.
are 11 students. Okay, good. What else are we asked to find? What is the modal number of correct answers?
The modal, it would be the correct answers that occurred most frequently. And in this case, we see where 14 students would have had
yes.
Right.
Yes.
9.
9, which would be. And then we come to what is the median number of correct answers. Now you can work this for yourselves, ladies and gentlemen at home. What I want you to understand and appreciate is that we have given you the opportunity to use multiple strategies in order to problem solve.
That's all for today. We've been problem solving in measurement and statistics.
Don't forget to tune into our School Time channel on One Spot Media for additional subjects for all ages. Check the timetable. Until then, keep safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.